Here we'll just deal with the complex simulation inside this SolidWorks. So here you can see there are multiple components inside. This one is made of concrete, and this is bottom steel support coat, and these are the beams, and these are the stiffness and ribs, and these are the supporting legs. And even we have the beams, okay, which can help us to deal with the loadings, to just translate these all the uniform loads on the beams so that it should have a proper distribution of load. So now to deal with this, you can directly jump to new study and create it accordingly. Otherwise you can simply create a copy of it. Let me create a new study itself. So we just rename it as test. So here if we are dealing with the isotrophic materials, we could take the steel components into account, okay, and if you are dealing with the concrete, that is not an isotrophic element, so we cannot include that one inside it. And if you are going to mesh this component also, it cannot take too much time, right? So to avoid this, what we can do is we simply just select these components and we'll exclude them from the analysis. So let me just check where they have exactly placed. Otherwise what I can do is I can simply select this one, so it is here. I'll select these all and I'll simply exclude these all from the analysis. I don't want them. And even same thing with this. So we need to simplify our model as much as possible so that we can get a proper outcome, right? So instead of taking each and everything into account and meshing it and simply running the simulation until the software crashes, that doesn't help us. Yep, so I have simplified it. Let me just apply the fixtures for now. So you can press the shift C to just close all the tabs, okay, and let me just connect the charger. Yeah, I'll apply the fixtures for now. So I'll define the fixtures for these. So you can even define the, so I'm not gonna consider beams into account. You can do that also. So again it gonna just reduce the time span, but let me just go ahead with the solid mesh only and let it take as much time it requires. So there are multiple sheets are there in the cut list. These has been turned into beams. Yeah, good night. And I'll treat them as solid now. So let me do that. Okay, these all are solid only. Yeah, so from here to here, and I don't want these lines which should be included in it. Okay, so you can simply right click on it and select create selected bodies as solids. Now all the component has turned into good night. solid elements. So we can utilize the loading condition. So let me just define the force. So what I'll do is I'll simply select the faces of these beams to define my loading condition on it. So on these beams it should distribute the force. Don't want these edges, so you can simply select them again, delete that, and these faces as well. Yeah, I'm done with this. So these all the beams should have the total load of 75,000 Newton, otherwise I'll take 7,50,000 Newton load. I don't know how much I need, but I'll consider this much for now. Let's see what happens. So once you define the load as well as the fixture, I don't need to deal with the contacts for now, so I'll simply take the global contact bonded into account. I'll mesh it by using blended curvature based mesh. So I'll utilize the medium size mesh. So it's gonna take some time to mesh it. Let it take. Yeah, you can see this has been meshed, but it is quite coarse one. You can even refine it. For now I'll consider this much to get the results, not an issue for me. So right now I'm using the automatic solver, and that also you need to keep it to mind. We can define the different solvers like automatic and FFE solver, and direct spars, and the Intel direct spars, and large displacement direct spars also. That I'll just showcase how to utilize them. So for this I think I have selected large displacement direct spars analysis. Let me just check that one later. So it's gonna take some time to run the results, so we'll wait. Yep, we got the results. So for 7,50,000 Newton loading, the 250 megapascal is the yield, and you can see On an average of 300 megapascal is the maximum one must stress. So I haven't applied any proper material condition for this. So for these component we have utilized mild steel, so that is okay for me, not an issue. So whatever the load I have applied, it is too much for this. You can even check with the factor of safety. Factor of safety is 0.83. so actually this is not the loading case, so actually it was like kind of 6 lakh or maybe less than that. So I just taken this one into account simply. You can even animate the results. Okay, this is not the practical displacement. Okay, so displacement maximum is 6.4, so it is quite more with respect to that loading. If you want to have the practical actual scale, you can select the true scale to have a actual displacement animation. So this is how you need to rectify your model and you need to deal with the results. You should not consider entire model which they have given into account randomly. That is of our negligence. Even though we are perfect CA analysts, sometimes we do that mistakes. If someone gives any of the components to deal with it, directly take that one into account without any analyzing or simplifying the model, and we'll start running the simulation. So that we shouldn't do it. So according to the loading condition, we should simplify the model and we should go ahead with the results. And as I said in the properties, I told the solver is automatic here. By manual you can set it. If you are dealing with the large displacement analysis, what we can do is we can simply select more options and direct space on the large problem direct sparse. So these will help us to deal with the large displacement or the large complex assemblies. And FFE solver is more accurate results for the models with the simple complex shapes that we can do it. So this is a small glimpse about it. So this is how we need to deal with this kind of components. So remember, simplifying model and dealing with the appropriate material conditions and applying the proper mesh is very important. Yeah, thank you.